Hello everyone, welcome back to our channel. I'm Zeb Patti. The metaverse is a very ambitious goal involving complex technologies in a vast and fluid virtual ecosystem. It is very likely that in a few years, people in the Western and developed world will be spending a large portion of their time living and earning in the metaverse. The promise and success of the metaverse, however, will require many advanced technologies to come together, and that is a monumental task. But by developing an appropriate and ideal framework and establishing industry standards that ensure seamless integration of current and future technology, this task can be accomplished and the metaverse dream is achievable. Think of the metaverse as a giant non-stop global machine with hundreds of gears, sensors, levers, gauges, and millions of operators all over the world that mimics our real world. A gigantic application where the technology supports the ecosystem in which digital twins of people, places and things in the real world exist. This will require immense planning and collaboration between both people and technologies. This video discusses a proposed framework for the metaverse. Obviously, it is just one of the many other framework options. In this proposed framework, we'll elaborate on 14 technologies and ecosystem factors that have been identified. We'll break these 14 into two groups. First is the technology group, and the second group is the ecosystem group. The technology group consists of 8 focused technologies, and the ecosystem group has 6 factors that pertain to it. Let's call these combined as the 14 metaverse essentials. Due to the interdisciplinary nature of the metaverse, it is important to explain the relationship between these 14 essentials, as they must seamlessly integrate to form a unified, massive and powerful system to support the metaverse and its ecosystem. Successfully connecting the appropriate technologies to the ecosystem will be the decisive factor that will determine the final success in actualizing the vision of the metaverse. There are amazing developments in computing power, cloud storage, high-speed latency-free networks, edge computing, Internet of Things, artificial intelligence, generative AI, massive online gaming tools and platforms, virtual reality user interfaces, self-sovereign identification, and decentralized ID technologies, and blockchain and decentralized autonomous organization, DAOs, and other distributed ledger and governance technologies. There are also significant and ongoing improvements in social media platforms such as Facebook, LinkedIn, TikTok, WhatsApp, Instagram, and so many others that will all eventually be weaved into the metaverse or cease to exist. Given this backdrop, now let's review the proposed metaverse framework and the 14 key and critical elements that form and shape the framework. In this video, we'll look at the 8 technologies, and in the following video, that is part 2, we'll explain the 6 ecosystems factors. First, the 8 technologies. These technologies will form the 8 pillars on which the virtual universe, our metaverse, will stand. These 8 pillars will collectively support all the virtual worlds and virtual beings and entities in the ecosystem. They will function and operate seamlessly as a massive and unified, powerful application. The human users will access the metaverse through extended reality, XR, and other such technologies for all interactivity, that is, manipulating their digital twins and virtual objects. Here are the 8 key pillars that the user interactivity and experience will rely on. 1. Extended reality, XR. 2. User interaction in XR and ubiquitous interfaces. 3. Robotics and Internet of Things, IoT. 4. Artificial intelligence. 5. Computer vision. 6. Blockchain to manage assets and activities in the metaverse market economy. 7. Edge computing. 8. The future network. So, let's explain these 8 one by one. 1. Extended reality, or XR. XR is a collection of immersive technologies such as virtual reality, VR, augmented reality, AR, and mixed reality, MR. VR immerses users in fully synthetic environments, allowing for content creation and multi-user collaboration. AR enhances the physical world by overlaying digital content with various devices enabling this technology. MR, situated between AR and VR, allows for greater interaction between virtual and physical entities. It is important to emphasize seamless user interaction, environmental understanding, and the challenge of managing dynamic states and events at scale when we implement XR. Because when we bridge the digital and physical worlds, a seamless experience is what the users will be expecting, and XR technologies are at the center of enabling this experience. Number 2. User interaction in the Metaverse. Here we explain the user interaction technologies in the context of extended reality, XR, and the Metaverse. The importance of reducing latency, improving computational efficiency, and enhancing user experience in these emerging technologies is crucial. For example, introducing mobile input techniques, including freehand interaction and various sensor-driven devices integrated into headsets for precise movement capture. The importance of mobile AR/MR headsets is important for their ability to provide aligned views between physical and virtual realities. This emphasizes the significance of feedback cues, particularly haptic feedback, in enhancing user experience and interaction in virtual environments. Haptic devices, or haptic interfaces, are electromechanical devices that mediate communication between the user and the computer. Haptic devices allow users to touch, feel, and manipulate three-dimensional objects in virtual environments and teleoperated systems. In the Metaverse, humans and real-world entities will have avatars and digital twins, so we have to introduce the concept of telepresence. There are many challenges, and the foremost of these is synchronizing haptic stimuli. Here we need advanced communication technologies like 5G and 6G wireless networks. To this end, a visionary concept of tactile internet, or redesigning the backbone of the internet, to add ultra-reliable tactile sensory for virtual objects for telepresence may be ultimately required because of the sheer volume of interactions. Finally, we must introduce brain-computer interface, BCI technology, as a potential solution for fully simulating all sensory experiences in the Metaverse. BCI, in fact, could become the optimal device for human virtual world interaction. As of July 2024, the latest developments in BCI came from Neuralink, a company founded by Elon Musk, which demonstrated a human with a bee implant playing video games for 12 hours continuously. Elon Musk has stated that his ultimate goal for Neuralink is to augment human capabilities to the point that they can compete with advanced artificial intelligence. Number 3. Robotics and Internet of Things, IoT. As the Metaverse begins to emerge, the diversity of interaction modalities will undoubtedly expand, necessitating the integration of IoT and AR, VR, MR technologies to create compelling user experiences, especially for non-expert users. This integration allows interaction systems to combine the real-world context of the agent with immersive AR content, significantly enhancing usability and functionality. For example, AR, VR, MR-directed IoT interaction systems. These can be categorized by two key principles: A, mid-air icons and menus. These allow users to control IoT devices with natural gestures, and B, virtual overlays. In AR, MR, XR, these facilitate data presentation and enhance human IoT interaction. For instance, VRA, a visual and spatial programming system, enables users to perform task authoring with an AR handheld interface. The AR device can be attached to a mobile robot to execute tasks in a what you do is what robot does, WYDWRD manner. Similarly, flying drones, popular IoT devices, can be controlled remotely by multiple users for collaborative outdoor tasks. Also, modern vehicles equipped with powerful computational capacities and advanced sensors can connect with the Metaverse through 5G or more advanced networks. This connectivity can transform driving information into engaging animations without compromising road safety. The concept of invisible to visible, I2V platform, exemplifies the integration of intelligent vehicles and virtual environments. I2V connects the physical and virtual worlds, making invisible information visible to drivers. Using omnisensing technology, I2V gathers real-time data from traffic and surrounding vehicles. The Metaverse system analyzes this data to provide immediate insights into driving conditions. This digital transformation can enhance commutes by visualizing road information, hidden obstacles, traffic congestion, and even facilitating virtual human communication through MR. For example, family members can join the metaverse as avatars, and local guides can assist drivers virtually. Further, virtual environments such as AR, VR, MR open communication channels between robots and virtual environments, thanks to their content visualization capabilities. Human users, through systems like VR, can collaboratively develop task plans in AR environments and program mobile robots to interact with stationary IoTs. In VR, programmable mobile robots link stationary IoTs to perform collaborative tasks, illustrating the potential for robots to serve society proactively in various applications and services. In summary, the integration of IoT, AR, VR, MR, connected vehicles, and robotics within the metaverse presents transformative opportunities. These technologies, when combined, can create enriched, interactive experiences that bridge the gap between the physical and virtual worlds, paving the way for a more immersive and connected future. Number 4. Artificial intelligence. Artificial intelligence, AI, has achieved state-of-the-art performance in various applications, including natural language processing, image, video and audio synthesis, computer vision, and recommender systems. The emerging metaverse is characterized by vast amounts of sophisticated data, providing opportunities for AI to relieve operators from complex data analysis tasks such as monitoring, regulating, and planning. Generative AI will play a crucial role in the creation and operation of the metaverse. There are numerous applications of AI in the metaverse, foremost being automatic digital twins, computer agents, autonomous avatars, and generative AI content, such as creating virtual spaces, and other user-generated content or UCG. Automatic digital twin. Digital twins are digital clones of physical entities or systems that interact with the physical world. They provide classification, recognition, prediction, and determination services for their physical counterparts. Deep learning can facilitate the implementation of digital twins by training models on historical data from both the metaverse and physical systems. Real-time data fusion from these sources enhances model inference. For example, remote surgery could involve creating a digital twin of a patient, where surgical operations performed on the digital twin are replicated on the patient by a robotic arm. Computer agents. Computer agents, also known as non-player characters, NPCs, are characters not controlled by players. AI enhances NPCs' ability to mimic intelligent player behavior, meeting expectations for high-quality entertainment. NPC intelligence spans control strategy, realistic character animations, graphics, and voice. Generative AI and autonomy of avatars. Generative AI, Gen AI, holds immense potential in the metaverse, especially for user-generated content, or UCG. Gen AI can create personalized avatars, game themes, immersive stories, poems, music, and intricate 3D environments such as classrooms, meeting places, and dynamic scenes, enhancing user experience and engagement. Additionally, AI can play a pivotal role in metaverse governance and security by ensuring transparent, ethical decision-making processes and detecting and mitigating security threats in real time, fostering a safe and well-regulated virtual ecosystem. Avatars, as digital representations of players in the metaverse, enable interaction with other players and computer agents. Gen AI allows players to create diverse avatars for different applications or games, such as human shapes, imaginary creatures, or animals. In social communication and remote presence applications, avatars reflecting physical human facial and motion characteristics are essential. Current work focuses on avatar creation and modeling, advancing the realism and functionality of avatars in the metaverse. Number 5. Computer vision. Computer vision, or CV, is pivotal for achieving the metaverse, enabling XR applications to process and understand visual information to create immersive, virtual, and augmented environments. There are several key areas and components. Visual localization and mapping. Techniques like simultaneous localization and mapping, SLAM, are used to estimate device motion and reconstruct 3D environments. SLAM involves feature extraction, mapping 2D frames to 3D coordinates, and closed-loop detection to ensure accurate spatial understanding. B. Human pose and eye tracking. Essential for avatar control in the metaverse, these techniques track body and eye movements to create realistic interactions. Advanced sensors and deep learning enhance the accuracy of these tracking methods. C. Holistic scene understanding. This involves semantic segmentation and object detection to recognize and categorize elements in the virtual environment. Techniques like stereo depth estimation and action recognition further enhance the understanding of the scene. D. Image restoration and enhancement. To maintain high-quality visuals, computer vision techniques restore and enhance images, addressing issues like noise, blur, and resolution. This is crucial for creating realistic and immersive virtual worlds. The metaverse is a complex environment. Integrating virtual objects with the physical world requires precise and efficient spatial understanding algorithms. For body and pose tracking, reliable and efficient tracking algorithms are needed to maintain realistic interactions. For image quality, techniques for color correction, texture restoration, blur estimation, and super resolution are essential for high-quality virtual displays. Future advancements will focus on improving spatial understanding, body and pose tracking, and image quality to create seamless and immersive experiences. Number 6. Blockchain. Blockchain is a distributed database in which data is stored in blocks instead of structured tables. The generated data by users is encrypted and filled into a new block, which will be further linked onto previous blocks. All blocks are chained in chronological order with a consensus model. Blockchains can be viewed as a trust machine. The characteristics of blockchain include decentralization. The data is stored and updated in a decentralized manner without any central manager. Anonymity. In blockchain, transactions are completed without using the real identify ID of users. Users' personal information, IDs, assets, and transaction information are well protected. Immutability. Once the transaction is completed, the data can never be tampered, deleted, or altered. Auditability. Each transaction on the blockchain is recorded with a timestamp and can be verified for auditing through the hash value of the block in which it is stored. Autonomy. Data can be shared in a more safe and convenient manner on blockchain through consensus algorithms and protocols without the participation of authoritative third party. The public blockchain is a kind of complete decentralized blockchain, owning to the open characteristic. Blockchains are expected to connect everything in the world in the metaverse. Everything, including digital twins for physical entities and systems, avatars for users, large-scale, fine-grained map on various areas, etc., are all digitized and stored permanently. Unfathomably vast amounts of data will be generated in the metaverse. For storing this data, decentralized data storage techniques are now emerging. It is now possible to have a data storage system on the blockchain that guarantees the decentralization and security of the data in the metaverse. Additionally, non-fungible tokens, NFTs, for digital assets and their ownership, decentralized autonomous organizations, DAOs, decentralized and self-sovereign identifications technology, SSID, decentralized finance, DFI, and many other decentralized concepts have emerged that guarantee an open, perpetual, and sustainable metaverse with any central authorities controlling the technology or operations. Number 7. Cloud computing and edge computing. Two crucial technologies that will make or break the metaverse dream are cloud computing and edge computing. Both have revolutionized the way data is processed, stored, and analyzed, but they serve distinct purposes and have different strengths. We'll explore what each of these technologies is, why they are important, and delve into the latest developments and uses of both. Cloud computing refers to the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence, over the internet, the cloud. These services offer faster innovation, flexible resources, and economies of scale with all the benefits of scalability, cost efficiency, accessibility, meaning data and applications are accessible from anywhere with an internet connection. And last but not least, disaster recovery and backup, because cloud services offer the backup and disaster recovery solutions, ensuring data security and business continuity. Recent developments in generative AI, demand for training large language models, LLMs, has further improvised cloud computing business models to enlist powerful GPUs and TPUs, allowing for users to create rich multimodal content without investing in expensive hardware. Edge computing, on the other hand, brings computation and data storage closer to the location where it is needed to improve response times and save bandwidth. In essence, it involves processing data at the edge of the network rather than in a centralized data processing warehouse. This is exactly what XR and immersive user experience requires: extremely low latency. By processing data closer to the source, edge computing significantly reduces latency, making it ideal for applications that require real-time responses, such as autonomous vehicles and IoT devices. Edge computing is becoming equally important, particularly as we move towards more real-time processing, such as for autonomous driving, smart cities, and industrial automation, where instant data processing is critical. Both cloud and edge computing will play a pivotal role in the metaverse and modern technological ecosystems. Number 8. Future network technologies. The metaverse, an expansive virtual world, relies heavily on XR, extended reality technologies, and robust network infrastructure to deliver immersive experiences. High throughput and low latency are critical to ensure seamless interactions and real-time responses. Here we highlight the role of XR technologies, network requirements, and latency considerations essential for the metaverse's success. As mentioned earlier, XR technologies, including virtual reality, VR, augmented reality, AR, and mixed reality, MR, are foundational for the metaverse. These technologies capture and process visual information to create realistic and immersive virtual environments. The key aspects include visual localization and mapping, human pose and eye tracking and tracking body movements, image restoration and enhancement, to ensure high-quality realistic visuals and virtual worlds free of noise and blur. And finally, a holistic understanding of the scene, which involves semantic segmentation and object detection to recognize and categorize elements in the virtual environment. In addition to the above, we need latency-free end-to-end connectivity. The metaverse demands a persistent and pervasive network access to handle computation-heavy tasks, access large databases, and facilitate real-time communication. Here the key requirements include high throughput, meaning massive bandwidth to transmit continuous high-resolution content in real time. The increased capabilities of 5G and 6G will enable various applications relying on real-time data transmission, such as AR, VR, and cloud gaming. Then low latency is crucial for interactive applications like online social interactions and gaming using AR, VR. Motion to photon latency, the delay between user action and on-screen response, must be minimized to ensure a seamless user experience. Designing networks for the metaverse requires prioritizing human activities and user experiences. This means a human-centric network with embedded quality of experience, QoE metrics, to help optimize user experience by measuring and managing network performance based on user perception. In conclusion, the metaverse's success hinges on the seamless integration of all of the above-mentioned 8 essential technologies: extended reality, XR, user interaction technology in XR, robotics and Internet of Things, IoT, artificial intelligence, computer vision, blockchain, cloud and edge computing, and provisions for growth in the future network. XR technologies with robust low-latency networks will ensure high throughput and minimizing latency to enable immersive and interactive experiences. Advances in 5G, network slicing, wave bands, and QoE integration will play pivotal roles in achieving these goals. Collaboration among hardware manufacturers, application developers, high-performance network backbone providers, cloud computing data centers, and content providers is essential to create a stable infrastructure for the metaverse. In part 2 of this video, we'll explain the 6 ecosystem factors surrounding the activity in the metaverse. Here we mean all interactions in social networks, gaming, and virtual environments in the ecosystem. These 6 factors include avatars representing the human users, UCG, or user-generated content creation, the metaverse virtual economy, the corresponding social norms and regulations, that is, social acceptability, privacy and security, and lastly, trust and accountability. We hope you liked the video. If so, we'll appreciate very much if you press the like button. Also, stay tuned to our channel for part 2 of this video series. We thank you for watching.